So chapter review from the chapter 1, problem number 1. For each of the following sequences, all of these 5, they want you to check all of these 4 aspects. Identify whether the sequence is arithmetic, geometric, or neither, and all of these 3 things. So, like I said before, guys, when the problem is extremely simple, I will not be solving it fully. Okay, I will just be giving you directions, maybe exemplify a little bit of the problem, and then you can continue with the rest, right? I mean, because it's way too simple, right? So in here, I'm just gonna select 2 of them. Let's pick up, let's pick this one up, and this one. So I'm gonna analyze the second and the fourth, and you're gonna be doing the same for the other 3. What do I mean by analyzing? I'm going to be answering all of these 4 questions. Identify whether the sequence is arithmetic, geometric, or neither. By looking at this sequence, guys, I can see, okay, by looking at this sequence, I can see that the difference between each pair of terms is constant. And that difference is in fact 2, right? Minus 16 plus 2 gives me this number. Minus 14 plus 2 gives me this number. And that's it, right? So this is in fact an arithmetic sequence because it has a difference and that difference is constant and it's equal to 2. So done. B, if it is arithmetic or geometric, find an expression for the nth term. Okay, so what is the formula for the nth term in an arithmetic sequence? Well, we have it in the formula booklet, right? We have it here. The nth term of an arithmetic sequence is equal to this. And remember that you can look this up in the papers. So I'm gonna be writing the formula. There you go. Okay, and now I can actually even fill in some of these numbers, right? Because what do I know about the sequence? I know the difference, like I said before. The difference is 2. And I know the first term, which is minus 16. So I can already write, with these 2 pieces of information, I can write this formula in the following way. Instead of u1, I substitute minus 16. And instead of d in here, I put 2. So there you go. This is the formula. When I have substituted these 2 pieces of information into my general formula. So I have covered B. C. If it is arithmetic or geometric, find the indicated term. In this one, they indicate that I should find the term number 10. Okay, so I need to find this term. The term number 10, how do I find it? By making use of this formula that I just found. So I'm just going to substitute. N will be 10, and that's all the substitution that I need to do. So here we go, minus 16 plus 10 minus 1 times 2. I won't be doing this in here. This is just basic algebra. I don't need to do it. That's on you. And D, if it is arithmetic or geometric, find the indicated sum. The sum that they want me to find is this, S sub 8, which means the sum of the first 8 terms of the sequence. This plus this up until the number 8. Once again, do we have a formula? Do we have a formula for Sn? The answer is yes. It's in here, right? It's either this one, I mean, you have 2 formulas in here, right? Or 2 versions. This first one up until a semicolon, and then this other one. And they are completely indistinct. You can use one in some circumstances when you know the difference, and the other one when you know the last term that you want to add, right? So S8, let's see which one I can make use of. So it's this one. I can make use of this one. I'm gonna write it in here, n over 2 that multiplies all of this thing. And why do I say that I can use it? Because I have everything, right? I have n, which is 8. So I have this, I have this, I have the first term, which is this one. I have n, and I have the difference, which is 2. And it's just all a matter of substitution. There you go. Then doing this correctly and slowly, and you will be getting the sum of the first 8 terms. That's it. Now, the other one that I wanted to analyze is this one. I didn't teach you guys at least at the moment. I will, maybe as a bonus very quickly. The sigma notation is not something complicated, but we didn't actually see it in, let's say, its proper time. So uh, okay, let's do this. I'm gonna make a video, okay, on sigma notation, on sigma. It's gonna be about 7 minutes, I reckon, and then watch it, and then go back to this one. So I'm going to assume that you already have done that. And let's write this, the sum from n equals 1 to infinity of 3 times 2 to the n minus 1. Okay, so once again, question A, is this sequence arithmetic, geometric, or neither? When you expand this sum, you're going to be getting the following values. It's going to be equal to 3 times 2 to the 1 minus 1 plus 3 times 2 to the 2 minus 1 plus 3 times 2 to the 3 minus 1 plus etc. And as you can see, guys, this is 3 times 2 to the 0 plus 3 times 2 to the 1 plus 3 times 2 to the 2 and so on infinitely, right? Okay, so what type of series is this? What type of series? This is a geometric series, clearly. Geometric series. Why? Because in order to get the next term out of the previous one, all you have to do is multiply by 2, right? If you multiply this by 2, you're going to be getting this. Make sure, please. And then if you multiply this by 2, you're going to be getting this, right? This times 2 is going to be equal to 3 times 2 to the 2, as you can see. So it's a geometric series. Okay, perfect. So that's it for the first question. Now question B, if it is arithmetic or geometric, find an expression for the nth term. Okay, the nth term is actually this one, guys. This is the nth term of this series. It's clearly given in here automatically. So it's actually this. C, if it is arithmetic or geometric, find the indicated term. Well, they want me to find the fifth term, and I have the formula for the nth term. So if I want to find this, all I need to do is substitute into my formula n equals 5, and that's going to be equal to this. 2 to the 4, that's going to be 16 times 3, which is 48. That's going to be 48. And that's it. And D, if it is arithmetic or geometric, find the indicated sum. They want me to find this sum, the sum of the first 10 terms. Okay, perfect. What do? Once again, I make use of my formulas, either this one or this one. What information do I know in here? Well, no. That's a mistake. I'm making a mistake. We're talking about a geometric series, guys. You see, I was making a very dumb mistake. Why? Because the formula to get the sum of a geometric series is not the same as the one with as the one with a as the one that it's arithmetic, which is this. This is the one for geometric sequence. This is the one. So let's write it down. The sum of the first 10 terms for a geometric sequence is this. It has this shape. The first term times the ratio to the n minus 1 over r minus 1. There you go. And then we just substitute. In here, right? N will be 10. So let's substitute into this formula. S10 is going to be equal to the first term, which is this one. That's the first term, which is 3. And then the ratio, what is the ratio in here? We already agreed that it's 2, right? That's the common ratio. So that's going to be 2 to the n, which is 10, minus 1 over the ratio minus 1, which is 2 minus 1. That's it. Whatever this calculation is, that's going to be the problem. The solution to this sum. And that's it. That's how this works. And that concludes problem number 1.